Hello everyone, welcome to In 5 Minutes. Let us take up the next numerical now. The question says an amplitude modulated waveform has the form, that means AM signal is given in its mathematical form as 10 into 1 plus 0.5 cos 2000 pi t plus 0.5 cos 4000 pi t bracket close into cos of 20,000 pi t. That's the expression given. There are various questions. The first question is plot amplitude versus frequency spectrum. So we have to plot frequency spectrum in simple words, or amplitude versus frequency. We have to find out the total modulation index M, and we have to find power of each spectral component, and apart from that total power, sideband power, etc. So we'll find total power, sideband power, and we'll also find the carrier power. So from the given mathematical expression, we have to find various things. Now this could be one very important question. If you remember, in one of the previous video clips, we have derived the mathematical expression for AM signal, which in general form can be written as Vc into 1 plus. So when I keep Vc outside, inside the bracket we had Vm cos 2 pi fmt. So when Vc is taken outside, we get the ratio Vm by Vc, and that is replaced with M cos 2 pi fmt into, and outside we keep 2 pi fct. That's a carrier term, cos 2 pi fct. So whatever expression is given to us is very much similar to this expression, but you can see there are two cosine terms inside the bracket. Instead of that, the expression that we had written, there's only one cosine term. That is simply because the expression that we have written is for single modulating frequency, whereas the expression given in the question has two modulating frequencies, FM1 and FM2. So the general form that we will have to use for the given expression must have two cosine terms inside the bracket. So we'll make it M1 cos 2 pi FM1t plus M2 cos 2 pi FM2t, and this should be multiplied by the carrier term which remains outside, cos 2 pi fct. So now if you compare with the given expression, we'll write down few important things. You can see M1 is 0.5 and so is M2, because even the second cosine term has a coefficient of 0.5. If you compare, FM1 is equal to, see, it is 2 pi FM1t. Pi t is already there. So apart from pi t, we need 2 FM1. 2 FM1 will be equal to 1000. So FM1 will be equal to 1000. Similarly, FM2, you can see pi t is already available. So 4000 is my 2 FM2 part. So FM2 will be nothing but 2000. So the modulating frequencies are 1K and 2K, FM1, FM2. Let us now first talk about the frequency spectrum that we have to plot. In the frequency spectrum, once again, we can have one-sided or two-sided frequency spectrum. If I draw one-sided frequency spectrum, in that case, let us see what are going to be different frequencies. There is always the carrier frequency in the middle. On the higher side of the carrier frequency, we will have Fc plus Fm. This time there will be two such frequencies. On the lower side, we will have Fc minus Fm, again two frequencies, because there are two modulating frequencies given. So this is nothing but Fc, this will be Fc plus Fm1, this will be Fc plus Fm2. This will be nothing but Fc minus Fm1, and this last frequency will be Fc minus Fm2. So these are the various frequency components that we will have. X-axis is frequency, and on the y-axis we have to mention the amplitude of each and every frequency component.